Assalamualaikum and good day to everyone. My name is Khairunisa Shafiah binti Kamaruniza with matrix number S70837. In this video, my group and I would like to talk about the topic of comparing and contrasting the engine of the BMW and AXIA automobiles, as well as providing information on how the thermocouple or heat sensor is utilized to measure or identify the engine heat. This is my group member. In this executive summary, I am going to compare two very different automobile engines. The BMW engine, a high performance, turbocharged power plant built for speed and engineering excellence, and the Pro2 AXIA engine, a compact, naturally aspirated 3-cylinder engine designed for fuel efficiency and everyday commuting. Now, why does this matter? Because, despite their difference, both engines rely on the same core physics principle, converting fuel into heat, then into motion through what we call the Otto cycle, managing heat carefully to avoid damage and maintain efficiency, and using heat sensor like thermocouples to monitor engine temperature in real time. The key takeaway is simple. Even though BMW and AXIA engines serve completely different purposes, they both depend on thermal physics and modern sensor technology to operate safely, efficiently, and reliably. Without precise heat monitoring, neither engine could achieve its design goals.
Introduction. Internal combustion engine operate as thermodynamic system that convert chemical energy from fuel into thermal energy, which is subsequently converted into mechanical work. In modern automotive engineering, achieving a balance between high power output and maximum fuel economy remains a primary challenge. BMW and Pro2 AXIA represent two completely polarized engineering methodologies within this spectrum. While BMW optimizes its powertrain for high thermal output, extreme torque density and performance, the Pro2 AXIA focuses on minimizing internal friction, weight, and thermal losses to maximize everyday fuel efficiency. Managing these intense thermal environments demands highly accurate real-time diagnostic system, making the inclusion of precise temperature sensor an absolute necessity across all automotive tiers. Literature review. The BMW engine operates based on the 4-stroke Otto cycle, where fuel is combusted to convert chemical energy into mechanical work. The cycle consists of intake, compression, combustion, and exhaust strokes. Advanced technologies such as twin power turbo, direct fuel injection, and variable valve timing improve combustion efficiency, power output, and fuel economy. The Pro2 AXIA engine also used the 4-stroke Otto cycle to convert fuel energy into mechanical energy. The engine undergoes intake, compression, power, and exhaust strokes to produce motion. Its design emphasizes fuel efficiency through features such as electronic fuel injection and optimized combustion, making it suitable for economical daily driving.
Assalamualaikum, my name is Muhammad Razadi Ikhwan Berazak. 70887. I will talk about literature review is history of automotive thermocouples and heat sensor. Early indicators. Early automobiles use simple mechanical bimetallic sieve or motometer radiator caps to warn driver of catastrophic overheating. The electronic shift is with the advent of electronic control units ECUs in the late 20th century. Semiconductor transistors and thermocouple become standard for precise data gathering. Modern system today sensor feed continuous voltage data into complex engine management system to adjust fuel ratio, cooling fans, and safeguard. For theory or principle of the BMW engine thermodynamic cycle, utilize the 4-stroke Otto cycle, maximizing modern efficiency through gasoline direction injection (GDI) and forced induction turbocharging. Valvetronic and double vanners. Instead of a traditional throttle body, Variable valve leaf valvetronic dynamically controls intake air volume, reducing pumping loss and optimizing thermal output. Heat management utilize speed cooling system and electric water pumps to rapidly heat up the engine block to optimal operating temperature 100 degrees to 110 degrees. Okay, next, theory principle of the Product AXIA engine 1KRPE, natural aspirate efficiency. Function on the standard 4-stroke auto cycle by maximize high compression ratio 11.51 for a small non-turbocharged engine block. Intake optimization feature a high tumble intake port design that mix air and fuel into a uniform swirl, accelerating combustion velocity and ensuring complete full burn. Friction and weight reduction. Utilize a lightweight aluminium block, offset crankshaft layout and low friction resin coat piston to minimize internal kinetic energy loss as waste heat. Okay, next, theory principle of.
Next, let's look at the Product AXIA, which takes a completely different approach. The AXIA uses a transverse 3-cylinder 12-valve DOHC design. It is specifically built for front-wheel drive compact cars like the AXIA itself. Notice the different right way, 3 cylinders instead of 4 or 6, and it is naturally aspirated, no turbocharger. For component design, the AXIA uses a resin intake manifold to reduce weight. The cylinder head and exhaust manifold are integrated compactly to save space under the hood. This is all about efficiency and cost effectiveness. Looking at the technical summary, the AXIA 1K REVE engine has a capacity of just 998 cc, under 1 liter. It has been in production for 2014 to present, and it is classified as an energy efficient vehicle. This engine achieves maximum fuel efficiency through lightweight design, low friction and a high compression ratio of 11.5 to 1, all with minimal complexity. Now, here is where both engines come together, the critical component heat sensor. Let's talk about the thermocouple construction. It is made of two dissimilar metal, for example, chromel and alumel. These metals are joined at one end called the sensing junction, housed in a threaded brass casing. When there is a temperature difference between the hot junction inside the engine and the cold reference junction, the thermocouple generates a tiny voltage. This is called the Seebeck effect. Then we have the coolant sensor, which is actually a negative temperature coefficient resistor. What does that mean? Simple put, resistance drops as temperature rises, giving us predictable electrical signal that the engine can read. Where are these placed? They are located in the cylinder head water jacket or thermostat housing, positional for immediate, unobstructed exposure to engine coolant temperature. And here is the key insight. These sensors are the eyes for the engine management system. They constantly watch for overheating. They translate heat into electrical signal, feed real-time data to the engine control unit, and when temperature gets dangerously high, the ECU acts instantly to trigger cooling system or adjust timing to prevent damage.
Meaning of each word in title. BMW or Bayerische Motorenwerk is a German automobile manufacturer known for producing luxury vehicles, motorcycles, and high-performance engines. BMW focused on advanced engineering, performance, and driving efficiency. Product AXIA. Product AXIA is a compact hatchback car produced by Product. It is designed to provide affordability, fuel efficiency, and reliability for daily transportation. Heat sensor. A heat sensor is a device that detects and measures temperature change in a system. In vehicles, heat sensor monitor engine temperature and send data to the engine control unit (ECU) to ensure safe and efficient operation. Engine heat. Engine heat refers to the thermal energy generated during fuel combustion inside the engine. While some heat is converted into useful mechanical work, Excess heat must be removed through the cooling system to prevent overheating and engine damage. The comparison of engines. Performance for BMW is high power and acceleration, while Pro 2 AXIA is moderate for daily use. Fuel efficiency. BMW is good efficiency with higher fuel use, and Pro 2 AXIA is excellent fuel economy. Technology. The technology for BMW is turbocharging, direct injection, variable valve timing, while Pro 2 AXIA is simple EFT and VVT system.
How to heat sensor or thermocouple identify engine heat. The seatbelt effect. When the hot junction inside the engine blocks experience higher combustion temperature than the cold reference junction, a tiny potential voltage difference is generated. Voltage interpretation. The engine control unit ECU read this microspeed change in voltage, calculating the exact internal engine temperature via calibration curves. Dynamic feedback loop. If the sensor relay a dangerously high temperature, the ECU acts instantly to protect components, adjusting the cooling loops or engine timing. How to heat sensor or thermocouple identify engine heat. The seatbelt effect. When the hot junction inside the engine blocks experience higher combustion temperature than the cold reference junction, a tiny potential voltage difference is generated. Voltage interrupt.
So, let's bring it all together. We have seen two approaches, same physics. BMW pushed thermal physics to the limit, using turbocharging, direct injection, and advanced valve control to generate high power while managing extreme heat. The Pro 2 AXIA takes a simpler path, focusing on lightweight design, low friction, and high compression ratio to achieve maximum fuel efficiency with minimal complexity. But here is the common thread. Regardless of whether an engine is built for luxury performance or budget commuting, both depend critically on thermocouple and heat sensor. Without the physics of thermoelectricity and precise thermal monitoring, modern design, whether in a BMW or an AXIA, could not operate safely or efficiently. Heat sensors are the invisible guardians keeping our cars running smoothly. That's all from us. Thank you.